Unit 8, Lesson 4, Applying the Pythagorean Theorem. We are saying the Pythagorean Theorem is true for all right triangles. That means as soon as you can see any right triangle, you can apply the Pythagorean Theorem. So let's see one type of problem. This question is saying a 10-meter ladder, so as you can see the 10-meter ladder, leans against a wall. It's 5 meters from the base of the wall. So can you see? It's 5 meters far from the base of the wall. How high does the ladder reach to the nearest meter? We need to know this high. So when you have something like that, you think first, do we have a right angle? Do we have a right triangle so we can apply Pythagorean theory? As soon as you see the building here and the wall, for sure the wall building is doing 90 degrees with the floor. So this is a case of right angle. And because this right angle inside this triangle, that means it's right triangle. So if I have 5 meters far from the wall and 10 meters is the length of the ladder, that means I can find h, which is the height that this ladder reach to the nearest meter. So let's apply first the Pythagorean theory. So we are seeing, as usual, I'm gonna choose, let's say, the blue. I'm gonna say again, since h square, which is the hypotenuse square, equal leg 1 square plus leg 2 square in triangle, we're gonna say ABC, let's say, and here I can show that here maybe A, maybe top B, maybe this one is C. In triangle ABC I can find what? The hypotenuse square equal leg 1 square plus leg 2 square. Here the h here it's not the same h here. Here I means the hypotenuse. So 10 square equal leg 1 square. I'm gonna say, let's say for leg 1 the 5 meter, so 5 square plus this height that I needed, which is BC. So the segment BC here, I'm gonna square it like that. Now I'm looking for BC. So in this case I have to find the value first. The 10 square equal 100, that 5 square equal 25 plus BC square. Now I need to isolate BC, so as you know I can use the inverse strategy. I can remove the 25 from this side, and from this side I will remove the 25. So in this case I can continue. I have 25 with 25 zero pair. That means this is going to give me BC square equal 100 minus 25, which is 75. So BC only equal the square root of 75, and they said to the nearest meter. So let's use a calculator and we can say I need the square root of 75. So 75 square root is 8.66. So 8.66, and because it's saying to the nearest meter, that means I can say 9 approximately meter. So is 9 meter less than the hypotenuse? Yes. So I'm doing good job, because if this dimension is more than 10, it's not acceptable for sure, because we said from the previous lesson that the larger side of the three sides of any right triangle is the hypotenuse. The other two sides are less than the hypotenuse. So 9 meter is acceptable in this case. So this was the first question. Let's go to another question. You have this rectangular prism, and you can see AB. It's something that is passing through the prism. So you can imagine a little bit the 3 dimension here, and we need to find AB. I have 6 for the length of the base, or the width of the base we can say, and the other one is 8. So 6 and 8 are the two sides of the rectangle, the base rectangle, and 10 is the highest of the prism. So now we are looking for AB. So before we think with this way, we need to find any right angle. So you know from previous that this is rectangle, that means this angle is right angle. And we also know that all the faces are rectangle, so in each corner you're gonna find the right angle. Now what about AB? AB, it has a rectangle, and this rectangle we can say it, I'm gonna try to match the same color. We can say that A, B, and C here, it's a rectangle, a triangle that I'm gonna color it with green, that it's right triangle. With this angle 90 degree. So in this triangle I have what? Do I have AB? No, actually we are looking for AB. I have 10, but I don't have CB, and this is a big problem for me. With two unknown, I cannot find these two unknown because I have only one known. So I have to find at least two known, and after that I can find the third. So BC, it's missing 2. So let's see another triangle that it can help me to find BC. What about this triangle, which is, we're gonna call it BC, and maybe here H. In this triangle, I'm gonna color it with red. In this triangle, I have BH6, HC8. So that means I have two known sides. That means I can find the hypotenuse BC. And if I'm gonna find BC, in this case for triangle ABC, I can have from AC and BC the hypotenuse which I'm looking for, which is AB. So let's start from the red. So I'm gonna use this one for the red, and I'm gonna say, since hypotenuse square equal leg 1 square plus leg 2 square, in triangle BHC, I have what? The hypotenuse I'm looking for. So this is BC square equal leg 1 square, I'm gonna say 6, so 6 square. Leg 2 is 8, so 8 square. So BC square equal 36 plus 64. If I'm adding this 2, I will get 100. That means the BC equal the square root of 100, which means BC equal 10. Is 10, which is BC, which is the hypotenuse, larger than 6 and 8? Yes, so I'm doing good job. Now let's go to the green. I'm going to change the color to green. Let's see the green triangle, this triangle. Again, I'm going to say the same thing, since the hypotenuse square equal leg 1 square plus leg 2 square, in triangle, let's see the green one, BAC, BAC. I have what? I need the hypotenuse. So AB is the hypotenuse. I need AB. This is what I'm looking for. Equal what? Leg 1 and leg 2. Leg 1 is going to be the BC that I found it here. So BC is going to be my leg 1. So that means 10 square. Plus the other one, it's also 10. So that means AB square equal 100 plus 100, which means AB square equal 200. That means AB equal, I have two ways. Or I can find the square root of 200, or I can say the 200 equal what? 2 times 100. I can take the 100 outside of the square root as 10 square root of 2. So I can do it with this way, or I can find the square root of 200 right away. So with the calculator, the 200 if I find the square root, it's 14. I say, okay, that means this one equal 14.14. And this is how I found AB. And as you can see, 14.14 is larger than 10 and the other 10 for sure, because it's the hypotenuse. I hope you understood how we can apply the Pythagorean theorem in any right triangle. Thank you.